Hello friends, in this video I'd like to solve the following problem from the Polish Mathematical Olympiad final round 2023, problem number 4. We wish to prove that if n is an integer greater than or equal to, and if numbers a1, a2 and so on are positive, and their sum equals 1, and moreover, if the sum a1 plus twice a2 plus 3 times a3 and so on plus n times an equals b, we wish to prove that the following inequality is true, where our sum goes our two indices is sum over I and sum over j, and between 1 and n, I is less than j. We wish to prove that the sum of I minus j squared times ai times aj is less than or equal n minus b times b minus 1. So my hints for this problem are as follows. First of all, notice that some kind of symmetry is going on with these terms, I minus j squared times ai times aj, and then that allows us to simplify our sum. And from there, it should be more manageable to show that our inequality is true. So give it a try and I will see you in a minute. Okay, so I hope that you have managed to solve it. Here is my attempt. First of all, let's take our sum. And let's do the following. This sum equals 1/2 the sum over all I not equal to j, and j is less than n. Okay, why is that? Well, because of symmetry, if I change I and j places of I and j, we see that we get exactly the same sum. So it doesn't matter if I is less than j or if j is less than I. We get exactly the same sum. So we have twice the sum here. So to correct that, to get my sum only once, I have to put 1/2 in front. Moreover, what I can do now is to omit the condition that I is not equal to j. Why can I do that? Well, it's because if I equals j, our terms of our sum are just zeros. We can introduce zeros how many we wish. And now let's simplify our sum even further. So we have 1/2 sum over I and j freely between 1 and n. And we have I squared minus 2 times I times j plus j squared, ai, aj. Okay. And now let's split our sum in a couple of different sums. First sum will have terms I squared, ai, aj. So let's put I squared with ai, and that is multiplied by the sum over j from 1 to n of aj. Okay. The second sum will be 1/2 2 times the sum which goes from I equals 1 to n of I, ai, and we have other sum which goes from 1 to n of j, ij, and finally our final sum will go, I will go from 1 to n, ai, and finally we have sum over j, j goes from 1 to n, j squared aj. Okay. And now let's notice some things. First of all, by our assumption, this sum and this sum, they are equal 1. Moreover, also by our assumption, these two sums are equal b. And lastly, this sum is equal to this sum because they are different just in the name of our index. So, all in all, we can combine these two sums and we get sum which goes from j equals 1 to n, j squared aj minus b squared. So our sum equals exactly that. And now let's recall what we wish to prove. We wish to prove that this very sum is less than or equal, let's see, we call n minus b, b minus 1. Okay, and let's work from there. So let's expand the left-hand side, the right-hand side, sorry, left-hand side is already expanded and simplified. And we have b times n minus b squared plus b. Okay, very well. And now let's do the following. We see that b squared can be cancelled on both sides. And now let's do what exactly? Let's subtract b. And we get the following. Sum where j goes from 1 to n, j squared aj minus b is less than b minus 1 times n. Okay, we wish to prove that. And now let's do a step backwards, namely, I will change back b to its form with the sum, and 1 I will also express it as a sum. What do I mean by that? The first sum is that, remember that b was defined as the sum from j equals 1 to n of j ij. Here we also have the very same sum j ij, and finally remember that 1 happens to be just the sum as j goes from 1 to n of ij. Okay. And now let's try to combine these sums, and we get the following. If we combine sum on the left hand side, we will get j times j minus 1 aj, and on the right hand side we get n times the sum from j equals 1 to n, j minus 1 aj. And also I will put this n inside my sum. Okay, and now why is it true? Well, it is. Why? Because first of all, by our assumption, aj and aj, they are non-negative by assumption. Moreover, j goes from 1 to n, so these terms are also non-negative. And finally, j is less than or equal n, so this part is obviously less than n, and n happens to be on the right hand side. Or more explicitly, if you are not convinced, you can put everything on the right hand side and write it as n minus j, j minus 1 aj. And now every term of our sum is non-negative, so our inequality is in fact true. So this inequality is satisfied, and this inequality was equivalent to our stated inequality in the beginning of our problem. So yeah, so it's a pretty nice problem, I would say. It appeared on the final round of Polish Mathematical Olympiad. I hope that you learned something and I will see you soon. Goodbye.